Oh, no.
Maybe. It won't be easier by myself, or with like one parent. You guys ready?
Yeah.
How did you summarize the beginning information? Nathan, go.
Experimenting new can, slightly narrower and taller. Experiment can equals H over R equals 4.
Yeah, I take it. The one thing I might add is a cylindrical can. Wait, but it wasn't in there. But it was.
But that's not part of the word.
I'm gonna at least think it's a cylinder, right? Wait a minute. How did he? And actually, Nathaniel kind of gave it away, but it's okay. How did he write H over 4 as R? I thought it was the ratio of the height to the radius is 4. Okay, yeah, it's on the picture. But isn't that technically the same thing as the words I just underlined?
Yes.
Because ratio, there are 3 ways of writing a ratio. Do you remember this from a long time ago? The word to, T-O, or a colon, or a ratio in a fraction form, right? So the ratio of height to radius, that's one way. Height colon radius is another way, but H over R is a much more efficient way. And is 4 equals 4. So yes, the picture gave it to you, but so did the words. What was the piece of information that you had to recall that I was referring to that hopefully someone somewhere came up with? Volume of a cylinder is... There we go. Pi r squared times h. Area of the base times the height. Remember that? How volume works? Area of the base and the height. Pi r squared. And anybody who had their Precalc book, I bet it's in like one of the front covers. Anyway, there's like geometry stuff in the front and back covers of every book. Okay. So even if we had all of that, even if you had gotten the volume of the cylinder formula and you had summarized all the information, right? If you didn't know how to read A and B, you'd have no clue how to answer the question, right? Without CAPTCHA? Yeah. So, back. What's letter A asking or telling you? Good. So those of you that like to write every single word, you would at least have the right words written down, but I still would have absolutely no clue if you knew what they meant. What do they mean by the volume of the can as a function of the radius r? We have a volume and we have an equation. Why is this not good enough to write down?
It's not for R.
Has to be in relation to who and who alone?
R.
R specifically. What's wrong with this equation?
It's the V.
Well, the V is okay because it says volume. That's good. The pi r squared is great because it says in terms of r, pi is just a number. You're allowed to have numbers in equations. You're allowed to have exponents in equations. But when it says as a function of r, who is the other variable allowed to be there? Dependent on only r. Who doesn't belong? H. So how do we get a function of r and r alone? Not just like letter r done, but in terms of only r. But if we divide by h, he's still there. Divide by 4. What are you thinking of? Why are you saying 4? Because it's not there. But where is it?
I was just making stuff up.
But no, the number 4, it came from somewhere. Even if your brain doesn't know it. It's in the problem. What about 4?
I don't know.
No. You have a whole class. You gave an idea, and I'm saying that 4 is important. So everybody else, why is it important?
The radius is 4.
The radius isn't 4.
Oh.
H over R equals 4. So if we divide the entire thing by R, then H is over the R.
H is equal to 4R.
Why is that huge?
Because then we could just plug it in.
H is gone.
4R.
H is gone, right? So can't we say that pi r squared times 4r, aka 4 pi r cubed, is the exact same equation, but in terms of r and r alone? Well, no, you're bouncing off each other, aren't we? You can call yourselves geniuses until someone else like takes your spot. Huh. What did I do? Plug it in, and when you have pi r squared for r, we always put the coefficient in front. And r squared times r was r cubed. Ooh, algebra 1b, we're doing exponents right now. That's a thing. Okay, so, ready, set, letter B. Now you know what the objective is kind of about. What changes? Go. In your groups collaborate, you only have 1 minute. Can you get the correct volume function it's asking for this time? Go.
Guys, this is what I got.
Can't, your group beat me, and I started so much later than you.
Remember, each one had R thing.
So you have to get to use the original type. Wait.
Aha!
Wait, so you can. Oh, so you can use.
That's what I got, guys. Yo, I'm a genius. Hey, where's the genius group again? Yeah.
You do that.
Yo, 1/16.
What group got there?
Us. Oh.
That's
That was your job, Spencer.
They wish they could be us. Yeah, he was cheating, right?
Don't start throwing out the cheating card just because you lost.
No, what do you mean? Our whole group finished.
Good job.
Okay, but what made this problem challenging in any way, shape, or form? Because it's been how many minutes since class started and we're just now finishing the opener? What made it hard?
We didn't know anything.
You didn't know anything.
We didn't understand the
We
problem.
had to like remember it on our.
Okay, it gave you something because it gave you this, and this was the key, wasn't it?
Yes.
Okay. It gave you this was the key. It gave you enough information to tie it to a geometric figure, cylinder, right? Every can is a cylinder. Then you had to remember the volume formula, and then you had to figure out what on earth. Okay, pause. So when they say volume, function of, what are they saying? Who's your y? This guy needed to be alone on this side, right?
Yes.
In terms of, who's the x? Who's the independent? What does the whole equation need to be in terms of? Whatever comes next, right? So, back to the page from yesterday that we were finishing up right when the bell rang, or I don't know, somewhere around there. Why do I have a translation page? Because words are coming. Do you have to maybe review some math from the past in order to be able to make all the connections? Yeah, but they're going to give you what you need, the figure or the volume, perimeter, area, whatever you need. And are they going to tell you, okay, this is going to be your dependent, this is going to be your independent, in terms of, dependent on, function of, it's going to tell you I need the equation with this variable and this variable alone, with coefficients and squares and additions and whatever else, yes. But only with that variable being the input. So what else is coming? Domain and hence range? Domain and hence range? Domain and hence range. We had more time and I was a really cool teacher. Well, I'll show you what I mean. Make one of these for all of you. P.S. You guys can probably tell if you look at my notes about how much space to skip, meaning, should you skip a line for each example? No? You should leave a space for each example, right? Like given, skip a line, implied, skip a line. Can we see it?
Yeah.
Good. I want you guys to, underneath both of those, can you draw for me a big old XY coordinate axis? Not huge, maybe just taking up a couple lines. A big old XY coordinate axis. An x-axis, a y-axis. And can you sketch on there for me any graph? Any graph. It can be a line, it can be a parabola that's up and down, a parabola that's right and left. It can be a square root function, if you know what that looks like. It can be a curve, any graph. Because domain, well, define domain. The best way to visualize it is thinking of a graph. You might be given equations, you might be given tables, but the best way to think of it is given a graph. Question. What's the domain of and what's the domain of? I usually show domain with D and a colon. What's the domain of and what's the domain of? Collaborate your groups really quickly. You should be done by now. Go.
Like how far it goes. Like right.
Directions, instructions, ideas. Keep going.
Your range is a little bit. So basically, she's asking for the So basically, this would be an exclamation.
So it means x is greater than 5.
Yeah.
It means no less than 5. So it's just not near times 5. But there we go, I got it. X is greater than or equal to negative 5, but less than or equal to 5. So you see where 5
But then what's the range?
I don't know about these.
This is probably the range is
Oh, so it's saying there. Oh, then what's the
why?
like you don't need that.
Why is less than or no?
Man, X equals
Alright.
right there.
So, given. If something is given to you, what does that mean?
That means they tell you.
It's stated for you.
Yeah, well, okay, good. So it's stated for you. Domain stands for what kind of values?
Left or right? Oh, set up all possible X values.
Now be careful, X isn't always named X. AKA independents aren't always named X. So we should probably say all the independent variables. Could be T's, could be, aren't they just R's and H's?
Yes.
Okay, so the independent bars, whoever they are, that's the domain. So if it's given, if it's stated for you, well, this one was easy. What would you say the domain is for the problem that's right here?
All real numbers.
Greater than or equal to 0.
The normal function would be all real numbers because positives, negatives, zeros, everybody is allowed to be plugged in. All inputs are legal until I told you this. Just kidding, only these are legal. So what's given is the function, but also the domain. Only these x's. Oh, okay. But what would the domain be? Wait, is this a function? That's awkward. It's a numerically given function. But yeah, it's a function because every x is paired with one and only one. Okay, so it's a function, but what's my domain? Analyze it.
You have to draw it.
Not even. It's only these 4 points. It's not allowed to be connected. It's not everything in between. It's literally just 4 points. That's it. Okay, fine. This. I know, I was being tricky. What are you more used to thinking about with domains? Just plain old functions without little extra things added and just plain old graphs. So I heard some people saying things like, domain is how far, and I was like, oh, I like it. I'm not sure what you kept saying after that, but didn't I ask you all to write for me an x and y axis, and then draw some random graph? Someone give me an example of a random graph they drew. Sure, an x cubed. Or a tangent. Kind of depends on what you meant by it. I'm guessing x cubed. Okay. What if I was to draw an x cubed? Don't want that one. I want this one. Okay. If I was to draw an x cubed, let me close the algebra book. Let's look.
Whoa.
What? You guys are cute. You were so easily amused.
Oh, it's lagging though.
I know. Okay. So if I was to draw an x cubed, what question is domain answering? It's delayed, but you'll survive. Okay. So, domain. If I was a really cool teacher, I would have made one of these for all of you, but too bad I'm not that cool, or I don't have that much time. Domain answers how far left to how far right. Wait, why is it x equals to x equals?
Is the x-axis.
And how far left, isn't it going to be a vertical line? Right? And what are all vertical lines? X equals. Aren't they all x equals?
Yes.
Okay. So if we have a how far left x, that's going to be our left boundary, and a how far right x, that's going to be our right boundary, right? The question, if I was to keep on going this entire function's length, how far left and how far right should I go? Infinite. Because the function keeps going. So if the function keeps going, how far left, how far right? Well,
All real numbers.
technically, all real numbers. Does that make sense?
Yeah.
Now, if you want to be super snappy, and remember something that, focus, you should have seen last year called interval notation.
Oh,
You could say that the domain is snazzy symbol for all real numbers, or if you don't want to use that, you can just say all reals. But another way of doing it is x is within negative infinity to infinity. How far left to how far right. Now, we actually have a whole section coming with intervals, but we can review a little bit right now.
No, we're
Party pooper. But what if I was to do another type of example? And instead of doing the cubed one that Nathan said, what if I was to do something like, I don't know. How about I was thinking maybe on x equals y squared plus 1. Because it would be x minus 1 is I squared. Oh.
Plus 2.
Yeah, let's say if my units be 1/2. Can my units be 1/2?
Yes.
Okay, cool. So then that's going to be a 1 instead. So we'll say every 2 tick marks is a 1. There we go. So that works. Question, what's my domain for this one? Remember? How far left to how far right? How far left would you go?
X is greater than or equal to -1.
Because x can only go to -1, right? Now how far right could I go?
Infinitely.
Forever. So then, wouldn't it make sense then if someone had drawn that figure instead? My interval would be, well, do you guys already know?
-1, infinity.
I went by halves, so there was my -1, just to make it super obvious for all of you doubters. X equals y squared plus 1. Nathan was right when he was trying to give me the x is greater than or equal to -1, but the other way of writing it is how far left to how far right.
What's that?
Wait, well, this is or equal to, this can never reach.
Huh?
It's okay, we'll talk about intervals someday, not today. But does this one make sense?
No. Yes. No.
Okay, as long as that one makes sense, we're good. Aiden, what's up, bud?
What if you were just going to do a vertical line?
Huh?
What if you were just going to do one vertical line?
Whoa. Wait. What if I had just given you the line x equals 1? How far left?
Just 1.
1. How far right?
1.
Because x can only be.
That would be.
Okay. So, what kinds of functions have domain problems before we get into, oh, you guys might be good on those examples. What kinds of functions aren't going to be all real numbers? What kinds of functions aren't going to be all real numbers? Well, actually, the parabola only wasn't because I cut it down for you. I gave you something limited. Remember how Emma was like all real numbers, and I was like, yes, if I hadn't said for x greater than or equal to 0. So actually, parabolas are good. If you guys want, we could put a little list up here of non-domain problems. All reals are going to be the domains of all polynomials. Polynomials are always going to be all real numbers. Any quadratic, any linear, any cubic, any quartic, any pentic, any polynomial of a higher degree than that. All polynomials are always all real numbers. Like the cubic that Nathan gave me, or like the parabola, the 3x squared, if I hadn't cut it down. We're not going to talk about trig yet, because we haven't done trig. But the sine and cosine curves, they go on forever. They're all real numbers. The cubed root of x, actually the cubed root of any odd, I should say the odd root, the cubed root, the fifth root, the seventh root, the ninth root, any odd powered root would be just fine. We might add to this list of everybody who's all reals, but for right now, let's just say polynomials. There are some more, but for right now, polynomials are the main ones. But why are roots, even powered roots, underneath domain problems? Something that would restrict, something that would cut down, something that would limit the x's. What's tricky with even powered roots? We can use square roots as an example. Man, my whole computer is lagging today. I wonder. Can I just say y is equal to the square root of u? What's u? Well, it could be an x plus 1, it could be a 3x, it could be an 2x minus 3. It's a square root of something. What's not allowed under square roots? Negatives. So how are you going to find the domain? You're going to find the domain by taking whatever is underneath that root and setting it greater than or equal to 0. to take the square root of 0? Yeah, you are. What's the square root of 0?
0.
I don't mind 0. What do I mind underneath square roots?
Negative.
But wait a minute, hold on. Domain isn't for u's. Domain is for x's. So if this is 2x minus 1, wouldn't we have to solve for x? Or if it was 7x, wouldn't we have to solve for x? You have to solve. So I'm going to put a little like, this is your clue, this is what you do, but solve for x. And the reason I'm putting it out here is because you're going to need to do it over and over again. Because guess what? This one I'm going to say, what if you have something, anything, over u? What's the struggle with dividing by u? What's u not allowed to be?
0.
Yeah, you can't divide by 0. So my domain problem is u can't be 0, but I'm looking for x's, so you might have to solve for x. My clue with any denominator or any function with a denominator is to look at that denominator and say, you can't be 0. P.S. Whenever we're talking about zeros, you might have to do some sort of factoring, yeah? Set each factor equal to 0 and say, ooh, none of you, no zeros are allowed. Just because you guys are awesome, why not? Let's go a couple chapters in the future and talk about logarithms. Because logarithms, whatever log you have, and for right now I'll just say log base b, but maybe, I was on the b still, maybe, you remember ln, which has a special base.
Natural.
Or common log that has a base of an understood 10. It's not really shown. But any logarithm, including ln, which is a natural logarithm, still a logarithm, has a problem too. His problem is that he has a vertical asymptote at 0 and he cannot go negative. Any argument of a logarithm doesn't work for zeros or negatives because you cannot raise any base to a power and get a negative number out, at least in a continuous way, or get 0 out. But that's me. A couple chapters in the future, I should probably slow down. For right now, we'll just say, hey, here's another problem. When we get to trig, we'll have a whole other set of problems. Tangent, cosecant, and secant all have vertical asymptotes too. So that's a problem for another day. Today has enough worries of its own. Okay. Biblical integration. So, domain of a function. You guys are going to ace that one now, right?
Of course.
Because x is only allowed to equal what if we only have 5 points? Those 5 x's. And should any of these repeat? Nope, because if they do, they might not be a function if their y's don't match. Okay. We could do little like set builder notation, but we'll just say that's fine. The question, what would your domain be for letter B? Is it too small? Am I losing it? Any eyesight people still?
For B?
Yeah, B. Which problem? Or no problems, all real numbers. Denominator. Okay, so what do we do with the denominator? We set him not equal to 0, right? Follow the clues, they're right there. So domain. X plus 5 can't equal 0. For domain, I'm looking only for x's, so what can x not equal?
Negative.
Dun, 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 dun. Thank you. Does that make sense? So the domain problems. This is a very important page, by the way, because I refer back to domain problems quite a few times during the year and at the beginning of calculus and beyond. But as he has you have homework just on this, but we will refer back to this. You might need to make little notes, make it nice, colorful, important. Can we go down to letter D? Because letter C is a little bit weird and out there, kind of like the senator's representatives thing. You can write down C, volume of a sphere. Hey, it's a thing that you learned in the past, 4/3 pi r cubed. It's a little bit out there though. Let's go down to D. He's more normal. It's a function, like a normal function with like function notation and x's. Does he have a problem or all real numbers? He has a problem because what does he have?
It's a negative.
He has a root. That's more important than the negative for right now.
Yes.
So whenever we have roots, what do we look at?
Set it equal to u.
Got it. Come back and say, oh, sweet. Oh, not logarithms. Sorry. There he is. 4 minus 3x. The entire u lump needs to be set greater than or equal to 0, but domain is looking for what?
X.
X's. How left to how right. Horizontal measurements or coordinates. So can you do this legally? What would you do first? Minus 4 or plus 3x?
Minus 4.
People who add 3x, you'll never get your inequalities wrong. People who subtract the 4, I guess that's the way you were trained. So minus 4 is what the majority of most students I have seen would probably do. I hope we don't get your inequality wrong. Now what?
Divide by negative 3.
Then you're done?
X is greater than or equal to 4.
I might have just not heard you. What else do we need to do in this? When you multiply or divide by a negative, you have to set the inequality. I should say set. Flip the inequality. Why? Because of the very thing I said way up here. Remember the other way of going? Unlike equations, unlike equal signs, if we add or subtract to the left or the right, an inequality is placed very importantly. In equals, it doesn't matter what's on the left, what's on the right. We can flip it around. It's no big deal. In inequality, we can't just go flipping around things, interchanging the sides, because this is important. This quantity needs to be greater than or equal to that quantity. Do you see how we could have added the 3x, and if we did, positive x could have been alone after dividing a 3, but what would the inequality have been doing?
Flipping.
Yeah. So can you subtract the 4 and divide by a negative 3? Yes, but only as long as you remember to flip the inequality whenever you multiply or divide by what kind of value? A negative. Here was my clue. I didn't box it. U greater than or equal to 0. How are we doing?
Good.
Awesome.
Okay. Question. Why did I skip C? What would your gut say for volume of the sphere?
It's too hard
Who's ever blown bubbles? You can visualize a sphere. Think about the different radiuses possible, imagining that the bubble could go on forever and without a break. What radiuses of spheres are possible? All? Oh, you're right. Could be fractions, could be really big numbers or really small numbers, but what are you not thinking about? Is there a sphere if the radius is 0?
No.
There's no sphere. But couldn't the radius be a half of a tiny bubble? Or a third, or a tenth, or a hundredth?
X is greater than 0.
Not x, but r, but you're getting the right idea. Oh, I'm sorry. R needs to be greater than 0 for it to practically be a sphere. You can't have negative radii. Think about that. You can't have a 0 radius and still have a sphere. But as long as R is any quantity greater than 0, 0.1, 0.01, 0.001, you might have a tiny sphere, but you have one. What's different between this one and all the rest?
There is no equal.
Yeah, your quantities are different. You don't have like y's and x's, you have v's and r's. And also it's like a real world problem. You have to think about what actually works. Whereas the rest was like, ooh, there's a rule, there's a rule, there's a rule for that. So maybe math applied in the real world gets a little bit messy. But also interesting. Range. 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 Domain is all the x's. Range is all the Domain is all the x's. Range is all the y's. my silly way of remembering it. If you guys look at range with the y next to it with parentheses, can you take out the parentheses? How would you say that? Look at the range with the y next to it, take out the parentheses. How would you say it? Rangy. It's a cute little rangy. I don't know. My algebra 1 teacher said that a long time ago. It was domain x and rangy. Because the domain goes with the x's, range goes with the y's. It's silly, but if you ever had a way of remembering it, there you go. Cute little rangy. But anyway, these all the y's. If domain answers how far left to how far right, what will range answer? How far up to how far down, or how low does it go to how high does it go, yeah? How low does it go to how high does it go? P.S. There's been a key change made to your homework board just now. Which means homework tonight is to continue what you should have started last night. Start if you haven't started yet. Because this stuff, I need more than 2 minutes to cover. Come back, come back. For some of you, it's a sigh of relief. For some of you, it's just an excuse to procrastinate further. Please choose wisely. Okay. Rangy. Can we take some of the examples that we did just a second ago and throw them in? We could, for points, give the y's. I don't know, it's kind of boring. The harder part is what if you have a function and you have to visualize the range. So coming back, we have our domain, how far left to how far right, yeah? What else do we have?
Range.
How low to how high, yeah? Now, why are they y equals, besides the fact that it's rangy, and rangy is for y's, or sorry, range is for y's. Because, guys, if there's a cutoff of how high, what kind of line is going to be cutting it off? A horizontal line, which is a y equals line, right? But if I were to keep on expanding this, how low, how high does this guy go? Oh, all real numbers. What if I was to go back to this guy? How low, how high does he go? Infinite. Oh. Well, what kind of guys are going to be limited?
We're about to find out.
They're horizontal.
Do you see how this says visualize the graph? Like, I think the graph is kind of important. Have we done a lot of work of taking equations and getting to their graphs without a calculator yet this year?
No.
So this is something we're going to develop like all throughout the semester. Domain has rule. Use them, you're good. Range has visualize the graph and good luck. A lot of them are going to be all real numbers, but I'll give you one example that's not. How about f of x is square root of x? Domain. X has to be greater than or equal to 0. Range. How low does it go? 0. How high does it go? It's really slowly, but you finish. There are functions out there that have limited ranges, but you need to know what the graph looks like, and we'll be working all semester on what the graph looks like. Not all semester on the basic ones, but then we have to get into trig and talk about those. So range basically takes some more work. What are we doing tomorrow? Function notation. F of x. Do you know how to plug it in perfectly and never make mistakes?